So secondly, the contribution I said we should all make for JP and maybe Pepe. So if you contribute it, maybe we'll divide it between JP and Pepe. Abi, they were the ones taking you during that time, Abi, and they are going back to school. So they will be resuming by February. So we want to do our best to also support them one way or the other, not because they are begging. So whatever amount you raise, we might just divide it and give the two of them. Is there any other person that really joined them that is going to school now? So that's what we want to do. How many of you have contributed? You have paid the money. We said at least 1,000. Sacrifice it for them. Just be there for them. They are going to school. We said you should give 4 people. So, and don't be stingy. Many of you, you see money as if it's still huge for you. And a lot of times you remember give them to support their school fees. Is that taking? Please, please. Don't say, I don't want to spend much time on other talking this morning. So, but that's it. And I think I said today should be the last day, Abby. Or is it next week? Is it next week? So please, as much as possible, 1K, 1K. This generation, I'm not saying that you have money. I'm not saying, but it's something that if you want to sacrifice, you will see it. It might even be what they give you for food that day, and you say, this day, take this. I will fast and I will use it to pray for provisions and to support my parents for provisions. You don't know, those little acts can bring millions of blessings your way, your parents' way, and so God will help all of you. So then, lastly, to the Muslim brothers and sisters, we say Ramadan Kareem. Abi? So we say Happy Ramadan. How is it going? So whenever you are fasting, make yourself look good. Don't always smile. It's not like we start chemistry now. You'll be looking like we are taking out life out of your life. So smile, be fine. One of the things they taught us during fasting is that it is that time you actually need to show your energy more. You shouldn't be fasting and people be asking you, kilo share, àwẹ̀ náà ni. So no. So tí o bá fẹ́ kí àwẹ̀ rẹ kí ó ní ládá, please, you don't have to show it on your face that you are fasting. And I'm sure that some of you, since they started, you have not even done one. But God will reward all of you, and you will not have any reason to fail. And please, let's be careful this time. Your exam is here already before you know it, and your fasting comes with your exam. So at the end of the day, don't let anything affect you. Please, I know you want to eat sari. Maybe you always come from home, and by 4 o'clock or 3 o'clock, once you hear, o ti ń gúnyán, o ti ń ṣe gbogbo ẹ ti jẹ sari ní 5. And now, during the day, you are now sleeping because you ate sari and you woke up very early. You can beg your parents, just beg them. It does not mean you should not work. You can beg them. Whatever you want to do, you can do it early. Then, just tell them to wake you up when it's like 5 minutes to 5, just to eat your own sari and continue after you have prayed. But if you wake up 3 o'clock, 2 o'clock, and you start preparing, you might use your entire energy and it might affect the next day. I hope you understand what I'm saying. You can just beg them so that they can support you. When they are done cooking, they can give you your own food. You pray with them and follow your normal routine. However, please, I'm not your imam. I'm just saying my own. So don't go and judge me. I don't know how it operates. So however it operates for you, do it well. Just make sure that it does not affect anything. God will bless you. So is there any question on what we did on Kinet? At least you would have been solving questions. And if there's any problem you came across that you could not solve. Let's quickly look at it together. Question 26. They said that which of the following relationship between the pressure, volume, and temperature represents an ideal gas behavior? That's a general gas law. Behavior of an ideal gas. So an ideal gas obeys all gas law, Abi. So any of these form, because they are relating, they are not saying anything is constant. They are saying that what relates pressure, volume, and temperature for an ideal gas. That means general gas law. So if you look at all your options, option A says P and V over T. You should know that wants to really say like directly. So option A says P directly related to V over T. Do we think this will be correct? Let's check it. That means this will be equal to PKV over T. When you get to a level, ojú tó bá ti fi wò kángan wá ti mọ̀. I already know this is not correct. Immediately I saw it. Because this will give me PT over V equals to K. Abi, at the end of the day, that's saying that P1 T1 over V1. And is that the formula we have? So A is wrong. So it's not every time you waste time. But if you are just learning, you can take your time. Is that taking? You can express yourself. But Yoruba said that bá ṣe ń kọ́ṣẹ́ là ń kọ́ yàrá. So as you are learning, you also have to learn to be fast and smart in dealing with things. So that means that this is going to be P1 T1 over V1 equals P2 T2 over V2, and which means this is what? Wrong. And questions like this, they sometimes want to use it to waste your time. So they will put the correct answer at the last option. So that one might waste time. That's why you have to be fast. So if you look at option A, you already know. Option B now, for me, option B actually is correct. Ordinarily looking at it, I already know it's correct. Option C is wrong. It's saying that PT is directly proportional to, you will see that. Option C is actually saying the same thing as option A. Option D says that PV directly, that's also wrong. Then option E is the same thing as, okay, option A goes and say that P is directly proportional to VT. That is wrong because that's saying that P is equal to KVT. So that's saying P over V1 T1 is equal to P over, that is wrong. So the only option, so option B says that P is directly proportional to T over V. And you know what that means. This is going to be PKT over V, meaning that P1 V1 equals over T1 is equal to P2 V2 over T2. And as much as possible, please, I'm only saying this, I'm not saying you should not ask your questions anytime you have questions. But there are some questions you can ask your friends in the hostel, especially those of you in the hostel. There are some questions you can ask your classmates when you come to class. Now, if I gather 100 of you, I expect 80% of you to be able to solve this question. This question is not a question that I'm expecting that anybody should miss. Anybody. As long as you are in the class and you are practicing questions, it's not a question I'm expecting any. Instead of her helping you to answer this now, you could have saved us time. Your friend would, somebody would say even behind you, in front of you, let them go and say it. It's none of your business. The future will tell. So, law of combination of, I'm going to teach you with stoichiometry now. So, matter acting as particles in quarter sheton on here. But I think the person wanted to talk about law of combination, law of chemical combination that I said I would teach you with stoichiometry. So, is there any other question? Do you understand it, blessed? Do you get the point? They just want to prove the formula that do you understand it? So if you have any other question from your past question or from the questions you have been solving that you couldn't solve, you can let me know so I'll quickly solve it before I move on to the next thing. So no question again. So I want to believe we have all perfected kinetic theory because I've taught you since like 2-3 days ago. So by now, you will not have to practice questions. Already not have to play by. So you are the one that will give yourself problem if you are not studying every day. You will only problem here. So I pray that God will help you. Because what we keep piling up, Ishe Mama Posini, and your knowledge will keep growing with time. And one thing or the other will lead to another thing. I don't understand what this is. We used to teach sparking, like number 4 and number 9 remix. I don't know what that means. Is it some kinetic theory or what? Let me see the question. Sparking, oh, I understand. Maybe it's Gay-Lussac's law. I told you there was a time my teacher told me to go and pick all the questions on simple AC circuits, and I really did not know. I was just picking all the ones on current electricity, and I gave everything to him, and he looked at me like, well, we'll get it there. So, but these days now, you can't tell me to pick all questions on AC, and I will not pick it. So I understand. If you are calling sparking, I understand. Maybe question on Gay-Lussac's law. Sir, what of electrolysis? Are we still going to do it? A step at a time. So today I will do stoichiometry. Or you people already know stoichiometry. We should move on to electrolysis. So if we can do stoichiometry very well today, so by tomorrow, I have some parts that I want to do in biology, but by tomorrow, we'll decide on what to do, maybe chemistry, physics. But when we are through with class today, so we'll decide on what to do tomorrow. So let's start. Let's not waste time. And please, as much as possible, most times questions you see in stoichiometry in your JAMB, they are very simple questions. Since they started online questions on stoichiometry, since they started CBT exams, most stoichiometry questions are very simple. They are very simple because they know you probably do not have luxury of time, or you do not have calculators or some things. And most times, you don't see questions on stoichiometry. You can ask people that have been writing JAMB over and over. Most times, you don't see questions on stoichiometry. So if you see, it will just be one. But those days of ours, we already know. We used to answer 50 questions. During my JAMB, it was 50 chemistry, physics, 50. And out of my 50 questions, we already know how questions will come out. We already know 2 questions from atomic structure, 2 questions from this one, 2 questions, then 7 to 10 questions from stoichiometry. Then for inorganic, 7 to 10 questions. Then organic, 10 to 15 out of the 50. So you already know your sequence of how do we ask questions when we're doing paper tests. But these days, your whole 40 questions might be organic. Your 40 questions might be inorganic. Your 40 questions might be majorly electrolysis. One of the questions that you will always see in the exam is electrolysis. So don't joke with it. Don't say, at least I know chemical bonding very well. At least I can score 60. You can score 10. So you have to know everything, and calm down to know everything. So for the stoichiometry we want to do, we are not going to be saying much of stories. I'll give you basic definition, then I will explain it, and we deal with all the problems in short time. So please open your mind and open your brain. So when you're talking about stoichiometry in chemistry, you are talking about basic calculations. So you're just talking about measurements. Metry means measurements. This means elements. Why metry means measurements? So we need to do calculations in chemistry. We need to know what something contains. What is the amount of that thing? We can't just keep talking about CO2 and we don't even know the volume of the CO2. what's the volume of the gas in a container, you must be able to determine that. If I give you a sugar, what does that sugar weigh? What is the total number of carbon in that sugar? What is the composition of carbon in that sugar? What is the ratio in which they combine? All of those things are what they do. So you're trying to just measure or do some quantitative analysis. Quantitative. So qualitative means you will tell which element is present. Quantitative means you will tell what and by what amount is that element present. So your basic calculations in chemistry is what we do under stoichiometry. Is that taken? Now your calculations come in two forms. We have what we call composition stoichiometry. There are some calculations you do without having to balance chemical equation. We call it composition stoichiometry. I'll just give you the basic principles, the basic formula. We pick examples. So I don't know if there's any book, maybe past question or landlord or anything, so that we'll just be picking examples. I can also give you examples offhand so that you use it to understand each of those things. So we have two types of stoichiometry. We have what we call composition stoichiometry and reaction stoichiometry. So what's the difference here? This one is you determining one, you are trying to determine the components of a compound in terms of their what we call relative molecular masses. So you want to know the composition of a compound. They just give you a compound and they say that what is the total composition? What does it contain? If I have CaCO3, when you are asked to calculate relative molecular mass, they will give you their relative atomic masses. So they will say the atomic mass for Ca is 40, Abi. The atomic mass for carbon is 12. The atomic mass for oxygen is 16. They now say determine their molecular mass or relative molecular mass as the case may be. Now, if you have to do, in this case now, to determine the relative molecular mass, I don't need any reaction. I don't need to balance any chemical equation. So a question like that is called composition stoichiometry that does not involve reactions. So now, what do you do in this case? Let's take examples on that first part. So this is the first part. Now, determine the molecular mass of the following. I will do one for you, then you do the rest. NaNO3. So let's do that. Now, from what we have here, they can give you the formula and they can give you the name. This one is called sodium trioxonitrate 5. When we do oxidation and reduction, you see how they name them. This is called lead-true trioxonitrate 5. They can just tell you the name and not give you the formula because they expect you to know. Now, how do you know these formulas? Let me just give you a hint. In case it is the name they give you. SN.
Bluetooth mode. Ready, line in.
Let me see the mic. So, for now, we are going to talk about this when we get to electrolysis, but some part of it, I just want you to know. Potassium, sodium, calcium, all these ions. For anions, for Folake, so Nigeria can be in one. So these are the anions. So if I say, what is the formula for potassium nitrate? Potassium nitrate. Now come there. This is potassium, Abi. So the combining power, you know it's carrying +1, Abi. So that means the combining power is 1. You write that first. Nitrate, that is what? NO3 minus, Abi. Abi is the same thing as saying KNO3. So the formula for potassium nitrate is KNO3. Do you get that? Now, if I say lead nitrate, most times when an element has different oxidation states, you will put the oxidation states in brackets. That's why you will see lead 2 nitrate. Here now I said potassium nitrate. I didn't say potassium 1 nitrate because potassium really do not have different oxidation states. It only has one. But for lead can have Pb2 plus, can also have Pb4 plus. So if I want lead 4 nitrate, that means I'm telling you that the oxidation state on lead is +4. If I say lead 2 nitrate, that means I'm telling you that the oxidation state on lead is +2. So, but if I say lead nitrate, you can ask me, which of the lead? Is it lead 2 or lead 4? Because you know lead has different oxidation states. If I give you iron 2 sulfate, you already know what I'm talking about. That means that the oxidation state on iron is +2. But you know iron can also have +3, Abi. So iron 2 sulfate, meaning that the oxidation state on iron is +2. So if I say lead 2 nitrate, what would that be now? That means I'm saying Pb2 plus, Abi, and nitrate is what? NO3 minus. So the combining power for this is 2, combining power for this is 1. So if I change it, don't forget that this 2 applies to this, applies to this. But instead of, since there are multiple elements, I'll just write it outside. So I will say this is Pb, then NO3, 2. Do you get that? Because Pb is what? 2 plus. Do you understand that? Everybody, what will be the formula for iron 2 tetraoxosulfate 6? Tetraoxosulfate 6. All these are basic parts that you needed to have known before you even understand some things in stoichiometry. This one already described that the oxygen, this tetra means the oxygen is 4. You have 4 oxygen. Now look at it. Iron 2. This 2 is telling you that the oxidation state on that ion is +2. Do you get that? So you first write that one because you only have cations and anions. So now ion 2 will be Fe2 plus, Abi. Tetraoxo, meaning that 4 oxygen, then sulfate. When sulfur is joined to oxygen, we usually call it 8. Sulfate, nitrates, carbonates. Do you get that? Carbon joined to oxygen can be called carbonate. Sulfur joined to oxygen is called sulfate. Do you get that? So now, from what we have here, tetraoxo, meaning that when you join sulfur to oxygen, how many oxygen should be there? 4. That's what the tetra means. Then the sulfate 6. The 6 there is indicating the oxidation states of sulfur. So meaning that in this case now, you will know it when you do oxidation and reduction. So here I can say that Fe2 plus, then SO4 2 minus. You can see it here. This is tetraoxosulfate. This is fluoride. This is nitrate. Abi, this is carbonate. So if I say that iron 2 carbonate, you already know what I'm saying. So this is chloride, bromide, iodide, and hydroxide. So at the end of the day, when I want to change this now, the combining power for this is going to be 2. Abi, when we did chemical bonding, so that most times the oxidation states and combining power, they go the same way. So this is also 2. So when you change it, that's going to be Fe2, SO4, 2. Abi, but 2 ratio 2 is the same thing as saying that FeSO4. So there are some common names too that they use. Like now you can hear potassium permanganate. Potassium permanganate. What formula is that? That's KMnO4. So when you hear potassium permanganate, you are talking about KMnO4. But there's a way you can name potassium permanganate too. Potassium heptaoxo, what's that one called? I think it's KMnO4, Abi. So that's potassium tetraoxo manganate. Now, that manganate, you need to know the oxidation states. If you do oxidation and reduction, you will know. Tetraoxo manganate 6 is usually 6. How do you determine that? This one is +1, Abi. This one is -2. That will become -8, Abi. So 8 + 1, that means this one is going to be 7 to balance the charges. So that's potassium tetraoxomanganate 7. We can determine all this later, so don't worry. Just for basic parts. So just know this for basic parts for now. We will be coming across some common names. So now, let me add one more. This is 5, then this is 6. When you now see water, what will be the name of this guy now? Sodium tetraoxosulfate 6. Sodium tetraoxosulfate 6. Don't worry about these two. You don't need to say disodium. Is that taken? Sodium has 1 oxidation state. So when you are combining them, you will see that sodium is 2. This 2 does not mean that because it's from this SO4 2-, shade yet. Then the 2, when they exchange it, it became sodium tetrasulfate 2. But now this water, whenever you see that water is joined to them, we call it hydrate. So now, how many water join this one is another thing. So this one will now be called sodium tetraoxosulfate 6 dihydrate, meaning that there are 2 of these guys. Dihydrate. Do you get that? Now, if I add to this now, what will be the name of this one? How many oxygen do you have here? 3. Don't say 6. That's why I didn't say disodium here too. These 2 came here because of the oxidation state lead is carrying. Is that taken? So this is lead trioxonitrate 5 penta. Penta is 5. Pentahydrate. Do you get that? So just know all of these things for now. So when they mention them, you can combine them to do what you are supposed to do. So when we are solving problems, you see more of that. So now, you have to solve for this. Copper 2 tetraoxosulfate 6 pentahydrate. So you are also to solve for the relative molecular mass of. Note something, if they say molecular mass, it has units. The unit is gram per mole. But if they say relative molecular mass, it has no unit. That's just the major difference. So, from what we have here, let's solve for these guys. Can I rub this part? These are parts that you already know before, even if you are in SS1. They should know how to calculate all these molecular formula, but we are just starting from there. So can I rub this? I'll still teach you again. So now, whenever you want to solve for molecular mass or relative molecular formula, molecular mass must have been focusing on 1 mole. So we will call it relative molecular formula. So if you want to get the relative molecular mass of this guy, you just need to know the total number. So you are going to write, for all of them, NaNO3. So what you are just going to do is, to get the relative molecular mass, you will sum it together. How many sodium do you have? Write it. Plus how many nitrogen? Plus how many oxygen? Shall you get? Then their relative atomic masses will be given. For sodium, the relative atomic mass for sodium is 23. Shall you get? For nitrogen, it is 14. For lead, it is 207. Abi? For sulfur, it is 32. For copper, it is 64 or 63.5. Then which one again? Hydrogen is 1. What's copper? Okay, we have given that of copper. So that's all. So these are the things you will need to solve for them. Is that taken? So you will now write the one you want to calculate, to list it out. Then that of sodium. Sodium is what? You need to know it offhand. That's 23. Plus nitrogen is what? Plus you have 3 oxygen here, Abby. So 3 into what? 16. So sum that together. What do you have? 85. If you are calculating relative molecular mass, don't put units. But if they say molar mass, then you put gram per mole as the unit. Is that taken? So let me change this now. Determine the molecular mass for 1 mole. For 1 mole of the following compounds. So of the following. If I say 1 mole, then molar mass is correct now. You can now put units, gram per mole. Then that means what you have calculated here is molar mass. So when you see unit, it's molar mass. When there is no unit, it's relative molecular mass. So can we do for the next one? Oh yeah, please be fast. Tell me what you have for the Roman figure 2. If you are just learning, just take your time. Are you true? So while you are solving it, someone said I should give you the code to remember the cations and anions. Why someone gave me a stoichiometry question that if that's in the mixture, 3 grams of a mixture of calcium oxide and calcium tetrahydrosulfide 4 was heated to a black mass. If 0.44 of CO2 was liberated, calculate the percentage of CaO in the original mixture. Someone giving me this question now must have understood stoichiometry very well. So I will solve it for your sake, but we have not gotten there. But I'll just solve it for your sake. So let me hold that. So, but for this one, the code to remember those things I wrote, I said, Kayode, no compound may attract Zn for SnPb. However, chance has alternative action. So I actually developed that myself some just years ago. So it's been a very long time. Because some of you used to have some things, you used to know it in your secondary school. But me, I never knew it in my secondary school. So when I started studying on my own, I had to develop a way to remember it myself. So my own is Kayode, no compound may attract Zn for SNPB. However, Charles has alternative action. So someone is just telling that Kayode, there is no compound that can attract Zn for SNPB. No compound. In that sense, however, Charles has a way of allowing it to happen. So, Kayode, no compound may attract Zn for SNPB. However, Charles has alternative action. That means alternative way of making Zn to attract SNPB. So, it's because I have story behind it. That's why I'm explaining it. But you don't need the story. Kayode, no compound may attract Zn for SNPB. However, Charles has alternative action. Is that taken? So that's how I remember that every time. So the first one is talking about potassium. This is Na+. If you know it now, we will still need it when we get to electrolysis. This one is Ca2+, she gets. This one is Mg2+, this one is Al3+, this one is Zn2+, this one is Fe2+, Sn2+, Pb2+, H+, Cu2+, Hg+, Ag+, Au+3. Kayode, no compound may attract Zn for SNPB. However, Charles has alternative action. That's cation. Kayode, no compound may attract Zn for SNPB. However, Charles has alternative action. You can develop your own, or you can study what I just gave you. Everything in life requires study. So, the other one, Folake, so Nigeria can be in one. That's for anions. So this is for cations. So for anions, remember, Folake, like you're surprised. Folake, so Nigeria can you know when something shock you sometimes, so Akalolo. So Folake, so Nigeria can be in one. So that is F minus, SO4 2 minus, NO3 minus, CO3 2 minus, Cl minus, Br minus, I minus, and OH minus. That's the data in there. So I'll solve it when we are through. The data in there. So I'll solve it when we are through. And you go to exam hall, and I saw people that couldn't solve it. And the way they asked this one was that they said calculate the vapor density. Calculate the vapor density of SO2. And you remember molar mass is equal to what? 2 times vapor density. That means you just need to know the molar mass, which is what? 64. Then 64 divided by 2, 32. As simple as that. Many people could not solve it. Another mistake people make is that molar mass is equal to 2 times vapor density. Some people say that vapor density is equal to 2 times molar mass. So another kasha might be one for right. As simple as they are, you just be wondering. So, what's the answer to the third one?
No power. Please charge.
Shebi they said they charge this till overnight. So what happened? What's the answer to CuSO4?
No power. Please charge.
And we have a lot to do today.
No power. Please charge.
It's going to be very stressful without mic. So what's the answer
No
to
power.
CuSO4?
Please charge.
So let's just try to maintain decorum and listen. It's a sensitive aspect that most people used to have issues with, but it's not so hard. I can tell you that stoichiometry looks like the simplest of what you can know in chemistry, but you just need an open mind to learn it. So, what's the answer to this? 160. Then those of you asking questions, please try to keep your questions for now, except the question is related to what we are doing. For now, we have not done anything. You're already asking me 10 cm cube of CO is mixed and spark with. We will get there. When I've taught you something, you can ask me question on it, on those things we have done. I've not taught you Gay-Lussac's law, and you're already asking me. I told you that you need to understand stoichiometry first before we do Gay-Lussac's law. You don't know how to balance equation, and you are doing Gay-Lussac's law. You can't do it. So that's why I say you should hold on first. So some questions you're asking me, please hold on. At the end of everything today, please, did you share the link? So at the end of everything, then you can all ask your questions. But listen first. What's the answer to this? Did you all get this? What's this one? 160. You all got 160, Abi? If your answer is different, I don't know the answers also, it's what you say that I believe. But if your own answer is different, you can let me know so that we'll do it together. What's the answer to Roman figure 5? 178. 178. How about this one? 250. 250. 218. So, Emmanuel said I should solve this. Some of you are saying, somebody for Emma can see you more. Please, don't be bothered about what anybody will say. Even I, as a teacher, if I laugh at you, na ṣe nǹkan tó mọ̀ lélẹ̀ sọ pé ò mọ̀ ẹ ṣàkọ́ mi torí ẹ̀ ló ṣe sanwó lẹ́sìn. Don't come here and be for me Rambo, and at the end of the day ordinary SO2 dey solve. So yeah, now how many sodium do we have? 2 sodium, Abi. You can. Some of you used to make mistake of these dots. Ẹ máa rò pé multiplication ni. It's not multiplication, Belerukewe. You have made that mistake. It's not multiplication, you add everything. It's the compound. So don't multiply. So this, how many sulfur do we have here? So that will be plus 1 sulfur. Plus how many oxygen altogether? There's 4 here, but there's 2 here, Abi. That's 6 altogether. You can do them separately. You can do for this one first, then do for this and add them. Share you get. You don't multiply. So that would be how many sulfur, how many oxygen altogether? 6. You know, these 2 at the front affect this. So that means this is like saying you have 2 water, 2 H2O. It's saying like H2O and H2O. In this compound, how many oxygen do you have? 2. Do you get that? So that means 6 oxygen altogether. Plus how many hydrogen? Plus 4 hydrogen. That's how you do it. Or you can first do for this one, then you do for this, then you add them together. Don't make mistake of this dot. So, is that taken? What's the answer here? 1. Is that what you all got before? So please, you can do that. Then for this last one, 250. So that's how you do it. So let's see the formula. Copper 2 tetraisosulfate 6 pentahydrate. Everybody, what is the oxidation state copper is carrying here? Plus 2. That means you have Cu2 plus tetraoxosulfate 6. You already know that is what? SO4 2 minus. Abi? SO4 2 minus. Forget this one for now. But you already know what that means. That means the water of crystallization that is added to it. And you know I said something that the major reason some of you used to have issues is because there are some things you did not know before. Normally, before we even get to some things, àwọn kankan are not to ẹ̀kọ́ mọ̀. Ó yẹ ká ti ṣe water, ó yẹ ká ti ṣe, but we will still do water later. I just know that there are some things you can still read on your own. That's why I'm jumping some things. So, from what we have here, because we still do solubility and we still do water of crystallization. Dot 5. So that's the first thing. The moment you know your formula, then you can solve the problem. So can we move on now? We are almost spending 1 hour already and we have not even started. How many hydrogen? So you can just do that all together. That will give you the answer. Is that clear? So next thing, after you have now understood this, on how to determine molecular mass or relative molecular mass, then the next thing is how to determine percentage composition. So can I rub this? So please, if you have maybe Lamlad or any book, you can bring it out so that we'll solve all the questions on the parts I've taught you before we move on to the next thing. So, percentage composition. Percentage composition is just talking about the composition of or the ratio of the mass of one of the elements to the total mass expressed in percentage. So you're just talking about mass of 1 mole of an element over the total mass multiplied by 100. So the ratio of mass of 1 mole to the total mass expressed in percentage. That's what we call percentage composition. What is the composition of boys in this class? That means it will be the boys over the boys plus girls multiplied by 100. Abi, that's the composition of boys in this class. So the total number of boys over the total number of everybody multiplied by 100. So that's percentage. So if I say what is the percentage composition of calcium in CaCO3, that means mass of calcium over total mass multiplied by 100. So for simplicity, this is what you need to know. Percentage composition is given as mass of 1 mole of a substance. Mass of 1 mole of a substance over total mass multiplied by 100. So that is percentage composition. Now, all of you have calculated for relative molecular mass. So let's pick them one after the other. So if they say that, what's the formula of the first one I gave you? KNO3, Abi? NaNO3. So in that NaNO3, let's determine the percentage composition of sodium or nitrogen. So in those questions, the first one is NaNO3, Abi? Determine percentage composition of sodium. The second one is what? PbNO3(2). So you have to determine the percentage of nitrogen here. The third one is what? SO2. Determine that of sulfur. You have to determine the percentage composition of sulfur. I will solve one for you, so you solve the rest. I hope you are all following. I want to try and solve all those questions so that you will be getting it clearly. Àwọn nǹkan tó máa bí ní exam ojú àwọn eléyìí náà lọ. Kò sí nǹkan tó ń wà complicated. Which other one? Cu. So let's determine for sulfur in CuSO4. Then what's the next one? Na2. So let's determine for oxygen in Na2SO4. So you tell me all your answers. I will do an example, then you tell me your answers. The next one is what? CSO4.5H2O. So let's do for sulfur. Is that taken? Oh yeah, let's see how we'll do it. So what are you going to do? We have calculated the total mass of Na to what? NaNO3. àti calculate total molecular mass abi. So wàá wo títí sodium, you look at that of sodium, so you divide it by the total, then multiply by 100. That is the percentage composition of sodium. That is the amount of sodium present in percentage. Do you get the point clear? Now, if they say that calculate percentage composition of sodium here, they're asking you that what is the amount of sodium in everything? What is the amount of sodium in everything expressed in percentage? That means you will need to know that of sodium over that of everything multiplied by 100. What is the percentage of boys in this class? That means the total number of boys over the total number of everybody multiplied by 100. That's percentage composition of boys. So if I now say what is the percentage composition of sodium, that means that of sodium over the total multiplied by 100. I think that English is simple. So yeah, let's do it. So what would that be? What is that of sodium in the compound? 23. So you can say percentage composition of sodium is equal to what? 23 over what's the total value? 85. Is that what you got? So 85 times 100. Show to ye ben. So you use that of sodium over the total multiplied by. You get in charge. I don't know if there's. Professor, make sure. That was F2. No, everything for F2. You know how many ions do you have here? 2. So that means you have to go for the 2 together. So you just multiply that value by 2. So you not just do for F2. Oh yeah, have you done for everything? So let's move on to the next thing you have done for everything. What's the answer for Roman figure 2? By God's grace, we will run just one for everything. Are you true? Are you sorry? Oh yeah. What? Oh yeah. What's the answer to the 7.5? Not approximately 9. What's the answer to the 7.5? Not approximately 9. It is approximately 8.5. You did not. This man's landlord here. I have some questions that I want to ask you. That they might ask me in the exam based on the 2 things we just finished doing. Are you ready? get the let's go here now. Have you all gotten the answer for this? If you don't know how to solve it, let me know. So I can solve it for you now. Now, what did we do? Everybody, please. Look up. For PbNO3, what did I do? How many lead we have here? Plus, how many nitrogen? You know, this will be 2 times, so that means you have 2 nitrogen. This is the same thing as saying PbN2O6. 2 times 3 is 6. But instead of writing it that way, the short form is this. Do you get that? So now, how many nitrogen? 2. How many oxygen? 6 altogether. Abi? So the total is going to be 207 plus 2 into 14 plus 3, 6 into 16. What did I give you in total? 331 gram per mole. Is that clear? We all got this that first time. They now said that what is the composition of nitrogen in this compound? What's the value of nitrogen here? 28. There are 2 nitrogens, Abi. If I say what is the composition of boys here, will you just say 1 over total? You will know the total number of boys, Abi. As long as boy, you count all the boys. So if I say what is the percentage composition of nitrogen, will you just pick 1 nitrogen? You will pick all of the nitrogens present. Do you get the point clear? So that means that you are going to say that percentage composition of nitrogen is going to be the total mass of nitrogen over the total mass of the whole compound multiplied by 100. Abi, that of nitrogen is what? There are 2 of it. So that means it's going to be 28. So that will be 28 over 331 multiplied by 100. Show you there. Do you understand? Well, yeah, let's look at a question that cannot be complicated if they now want to test your ability to reason. But before that, what's the answer for the third one? 50. This one is a common question in JAMB. The answer is what? 50%. What's the answer to the next one? 20%. Did you all get that? Yes. What's the answer to the next one? 53. You all got that, Abby? Yes. The next one? 12.8. Are we clear now? Yes. Now that you have the understanding, we are let's see this question, and I want you to solve it yourself. So right. I'm going to give you the name of the compound and we solve it using the 2 things we just did. So right, what is the percentage by mass of aluminium? We are going to do law of chemical combination, so don't worry. The law of the 4 laws: conservation of mass, reciprocal, and what's that one? Multiple proportion and definite proportion. What is the percentage by mass of aluminium in aluminium tetraoxosulfate 6? In aluminium tetraoxosulfate 6. What is the percentage by mass of aluminium in aluminium tetraoxosulfate 6? Question mark. Your heart is just beating so fast, like, hey, how will I do this? First thing you have to get rid of is that fear. Please, everybody is always scared. Yes, everybody. I get scared too. Let me give you this thing. Aluminium is 27, sulfur is 32, oxygen is 16. Just know that the beginning can be scary, but with time, you'll get used to it. And it will be looking very, very simple. But there's nobody that does not get scared, especially when you want to deal with exam problems. The last JAMB I did, If not for teacher's experience, I'm not sure I would have scored up to 300 in that JAMB. I just saw physics. I started with physics. I like to do the ones that waste my time first before I do the ones that won't waste my time. That's for me. And I know physics, I know chemistry, I know okay. When I start with physics, number 1 question, I solved it, no answer. Number 2, I solved it. And before I started that exam, I was having this serious headache that I could not get paracetamol because it was in the afternoon. And I was in the sun too. And I did not sleep, and a lot was wrong with me. So before you go for your exam, make sure you are in good state of mind. It's important. Don't be pressurized. But if not for my experience and my growth and everything, I might not have done well in that exam. First question, no answer. And the answer was there, but my head was saying something else. Second question, no answer. Third question, they now gave a question and the diagram was scattered. I said, nice one. The list I've always scored would be like 97, 98 in physics. When I was already seeing first 5 questions was wrong totally, I already know that. Hey, fourth question, no answer for me. Fifth question, they wrote 1:2. They wrote 1.2. I was seeing 1:2. And I was solving, no answer. After like the first 5 questions, number 6, and I knew it. Number 7, then it started flowing. Then the questions are now questions that I have to analyze to answer them. They didn't come easy at all. People that wrote that same time and that same day, when they, funniest thing is that almost all of them, Chidetu wrote that time. Nofisat wrote that time. This guy, you know, you met him, Teju wrote that same time. That same time, because when I was doing it, I was thinking about my students. That, hey, if me, I can be facing this pressure, what will happen to these children? And I love the fact that when all of them came, they all complained about that thing too. But at the end of the day, none of them had below 300 because they were prepared for the worst. So composition, all this preparation before, it matters a lot. One of them scored 317, one scored 324, one scored 325. It was this girl that scored 303 or 313. And that year she got to UTME that year. So at the end of the day, I had to compose myself that I know I'm not okay, but báwo la ṣe máa lọ pé mi tí wà fún mílíọ̀nù ká má rí wọn máa. So the questions were technical, but we still did it. So please compose yourself. Fear, you know that fear tó jẹ́ pé wà bẹ̀rẹ̀ sí sweat báyìí or wà dé bẹ̀rẹ̀ sí gbọ̀n báyìí. So if you don't know how to compose yourself, all you want to announce of. When I now got out, an officer was now telling me that, Uncle, it's 1:2, it's 1.2, not 1:2. I said it's 1:2, I saw. And it's 1.2. When I now saw this with 1.2, answer was there. The other one, they only asked on dimension of, was it linear momentum or something. I solved it. I shall to multiply by 2. I did not know. I was just solving like, as if I'm not a teacher. So don't be pressurized. Maintain good health when you are going. Don't be scared. God will help you. The major reason some people fail is fear. And that's why sometimes I write these exams to be at your state. I've been there before. So please, God will help you. Don't be scared. Have you gotten the answer? What's the answer? Yeah? That's 15.8. It's in the option. Let me see if that's the answer. So the answer is 15.8. That's what they chose to. So if you have gotten it, you are right. So were you able to write the formula? That's the first thing. You must be able to write the formula. You already saw aluminium tetra, so some of you are talking too much. You have not started though. The formula is aluminium tetrasulfate 6. Meaning that you will write aluminium as the cation and tetrasulfate 6 as the what? Anion. Then you change their combining power. And aluminium as the cation is going to be what? That's Al3 plus, Abi, and SO4 minus. What's the combining power? 3. Combining power 2. When you exchange that will be what? Al2, SO4, 3. We have to put bracket because it's not just one element. There are 2. So these 3 affects the 2 of them. So you just put it in brackets. Is that taking? So this is the formula. So if you did not get this one right first, then problem is here. Then what do you do next? Calculate the relative molecular mass, Abi. Then how do you do that? That means that's going to be what? 2Al plus, how many sulfur do you have? 3S plus, how many oxygen? 12 oxygen. Shall you get? Then 2 into 27 plus 3 into 32 plus 12 into 16. Do you understand that? So now after that, what's the total you got here? 342. Please, if it is molecular mass, the unit will be gram per mole. So now, to calculate percentage composition of what now? Aluminium, Abi. That will be mass of aluminium over total mass, Abi, times 100. And that's going to be what? 54, right? Divided by 342, multiplied by 100. And that gives us what? Approximately 15.8%. Do you understand that? Well, yeah, let's solve this one. So if you can practice this one, then the rest of this will be easier for you. Are you there? So right, what is the value of X? What is the value of X? In the molecular formula, what is the value of X? X. In the molecular formula, PbNO3X. This is the formula. Can I rub this board?
Yes.
What is the value of X? In the molecular formula, PbNO3X. I know some of you now, you just see the formula. I said, 2 Luma 1 there. You just pick 2 and you move on. They can test you. What is the value of X? But let's say you don't even know where to go again. You just pick your 2 and you move on. If the percentage by mass of nitrogen, is 8.46, if the percentage by mass of nitrogen is 8.46, Pb equals 207, N equals 14, O equals 16. What is the value of X in the formula? If the percentage by mass of nitrogen is 8.46, Pb equals 207, N equals 14, O equals 16. So you are trying to solve that and tell me what you think, what you feel, and how you feel. So move on to the next thing after this one. So we'll be solving all these questions together. So think about to solve it and tell me your answer. You are giving up. What happened? Mo tún bẹ̀ sọ̀rọ̀ tún mọ́jú sọ. What happened? What's wrong with you? Nothing. If I should ask you that, where's your notes and what are you doing? Now, bẹ̀rẹ̀ sí sọ̀rọ̀ sí as a teacher. You are in my class, you are not right. Mo tún wá bẹ̀ sọ̀rọ̀ tún lójú sàn bẹ́ẹ̀ ni pé ọkọ̀ ẹ̀ ló ń bẹ̀ sọ̀rọ̀. I'm your teacher. So, you cannot behave like that to your teacher. It's very wrong. Even if you don't understand what people are doing, you should just look at it and try your best. Some of you will be fighting yourself. Now imagine that you're not down over in bed. And you are not the first that we cross from maths and commercial to science. You are not the first. You have made a good decision, which is fine. I was in SS22 before I crossed to science. I was in commercial before. I was doing accounting. I always thank God that I went from commercial to science later, because it was one of the decisions I always thank God for. Most of my friends in commercial, they are always just causing troubles, walking up and down. There was nothing good about our life. We are troublemakers. But when they said I should go to science class, when I got there, I help me there. We were calm and all of those things. So I had trouble. 2.00. And since we started primaries, I've seen a lot of students. One of them even know the tutorial now. He's a teacher now. He's in UAU. He studied mechanical engineering. I remember when he came to primaries, then he left art class to join science class. It was very tough for him at the beginning. It was tough. We wrote JAMB maybe like 2, 3, 4 times. It was tough, but he never gave up. He said he wanted mechanical engineering. Now he's very strong. He has now even become a teacher. He's organizing seminar now online for people that want to write JAMB. He's teaching a lot of people. And he's in UAU here studying mechanical engineering. So imagine that he could just lock himself up that time and be trying. He will not achieve anything. You better know what you are doing. Some of you will be adding emotions to them. You'll be crying. It happens. That you don't know it does not mean that's the end of the world. I remember Favour is in Lautech when Favour's first came. Even that one, before she left her mom, she was crying. Mommy, don't go, Mommy, don't go. When they brought her to the stage, she was really busy crying. She does not want to leave her mom. Mommy, I miss you, don't go. And Mama was shedding tears. Then they now wanted to make the problem worse. After she spent some time in commercial, then she said, I like the sciences and this and that. She now left commercial, she came to join science. Then the cry now increased. People that have been in science before God, and it was that same year she gained admission in science. She should be in 400 level. So don't be scared. Just work. Challenges are part of life. You don't know it. Yes, you will know it. Just build your strength, build courage, meet with people that can teach you. I told you I've read over and over before, and I did not understand anything. All the time, go there too. So keep praying and keep working. God's grace will Have you all done it? Yes. So how are we going to do it? It's the same way. They just want to twist your neck. It's the same way. Some of you get to exam now because of that and you'll be scared. They said that they gave us the percentage of nitrogen, Abi. What's the percentage of nitrogen given? Abi, 8 points. Please, if you did not get it, look up. And even if you got it, look up. You might have solved it yourself. Fine. If this guy had been 2, what would we have done? You know, we say 2 times, then we have 2n, Abi. 2 times 3, then that will be 6, then we have 6 square. But now it is x. So that means we'll say x times n, Abi. It's just simple as that. But now they're giving you percentage of nitrogen. And if they said I should calculate, what did they say I should calculate? X, Abi. And you know something, if they are giving you same problems, and you are compiling your problems, even if you don't understand this, and you are compiling your problems, even if you don't understand, listen, follow what they are saying. If for apple, you don't understand, molecular mass, we can say that we have 1 lead, Abi. How many nitrogen? That would be X nitrogen, Abi. If this thing had been 2, it would have been 2 nitrogen. Sure you get. How many oxygen? X times 3. That means that would be 3x oxygen. Abi. So let's sum that together. This is going to be 207 plus 14x plus 3 times 16. 48x. So that's what they are just trying to use your brain for. 207 plus 14x plus 6 now. Do you get that? You can't do anything again now because you can't add this and this together. So now go back to percentage composition of nitrogen, which will be mass of nitrogen over total mass, Abi, times 100. So at the end of the day, you are given this, Abi, that's 8.46 equals, what's that of nitrogen here? That will be 14x over, what's total? Do you understand that? That's what they are trying to make you do. So now at the end, you can do basic mathematics now. So you will now say that multiply 8.46, you know how to cross multiply now. Some of you now. 8.46 into 207 plus 62x equals 14 times 100. Are you there? So you have multiplied this by this. What do you have? Is that okay? This times this. Are you there? Equals 400x. Show you. So now look for collect the lactimes, Abi. So that's 1400x minus 94.8. Please, all of these questions sometimes are just to help you to grow. Everybody will be scholars. Everybody will be scholars. I've been saying it. That generation is coming that everybody in this world will be scholars. And by that time, nobody will see anybody as a scholar again. Maybe they will not be using another term, para-scholar. Because all of us will automatically know good. Naturally, we will just all know good. Can you compare our generation to some generations of our father? Your level of intelligence now cannot be compared. My lecturer, he was actually our trainer in my coach. He was saying that when they were in OAU, if they need a book in the library, they will line up outside library just to get one book. All of them will line up and they will be coming in one by one. You collect the book, you read it for a particular time, and you return it. Now imagine how education would have been tough, and those people are the ones that became professors today. Till I graduated from OAU, the only thing I did in OAU library was to sleep. I did not go there to borrow books, neither did I even go there to read. I know where I used to read. But If my roommates are not allowing me to sleep, I go to the library where everything is quiet, everybody is reading. And me and Papa will play games small and put head on table and we sleep. Then when we are done, carry our book and go outside, and all our mates will say, "Hey, Shannon, we will back." Then as we went to sleep, then later I will now go to where we used to read and go and read there. So, what's the moral of the story? Life is easier now for all of you. Book is all around you. You don't even need hard copies these days. A lot of you, if you need a Bible, the people already have soft copy. There's no book you need now that there's no soft copy. So you that is another thing. Let's go on please. We have a lot to do. So don't let me start motivating you every time. Oh, you are not in my sharp. Yeah, go to my wise like sometimes you don't know that sometimes when you are crying, you go through that we come to find that you know. But it's just that we see how to encourage you. That's the thing. There are some levels that when you are getting there, you know it's growth. Some things don't require that you start crying. That shows you have grown. You have grown. You should, when you see a problem, what do you do? How do I face this problem? That's the next thing. If you have grown past that level. Also, question is that the next thing? You look for someone that will help you. You make friends that will help you. So at the end, this will be one second what's the answer here? So divide both sides. That gives you what? So the answer is 2. Shebi, you understand what we have done? You see the simple thing we learned in class. You see what they have done it to for us. They can come in any form. Watch out, Marabale. Today, we should go to practice different questions. So if you have practiced different questions, when you get to exam or you go say you have confidence, you know that there is no question you want to bring and practice. So it's not just to be in class, it's to practice questions. So are you true? Oh yeah, let's move to the next thing. So number 3 is empirical and molecular formula. Are you true with the board? Oh yeah, no, oh yeah. We are still on part 2. Which one have we been doing? Composition, stoichiometry. And in the end, adjust your SS1 work. All of you did this one too in SS1. Let me give you a secret. Some people's JAMB question last year was full of this. They just kept asking them empirical and molecular formula, especially during work. You know, as I'm teaching you, sometimes I'll just tell you. Okay, please, let's listen now. Let's go on. Can I rub the body? So please, before I move on, hello, keep quiet, please. I'm begging you once again, in a short sentence or short statement. Everybody have one problem. The stage you are passing through now, so many people are passing through it. So many people even have greater problems than this. I will only beg you that you shouldn't be discouraged. Some people are in this class, if not because of courage and the fear of God for their life, you think it will be easy for someone like Samuel Joseph to score 330 something last year and still come back to class with you? If not because of courage of God, that okay, let me just do this and just building that courage. Aside Samuel, there are lots in this place, a lot in this class. Now if everybody starts sharing their experience with you, oh, it's a Ọlọ́run dẹ̀ ní jẹ́ kó rí nǹkan táwọn rí. That's just the prayer. God will not allow you to face. But however, the thing is that many of you always say amen to some things, and there is nothing you can do to avoid some problems. It might not occur early, it might occur later. And sometimes you just have to pray to God to give you strength to always bear all those challenges when they come. So some of you will not have even faced anything, then you'll be broken down. But for all of them, please, it's just the beginning of your success. And there's nobody you go and ask that is successful today that they don't have their own share of the cake. And those are the people that can stand and talk to you today. Those are the people that can teach you. If JP is teaching a class, the difference will be there. That's all that wrote JAMB wants. If JP starts to teach a class now, the difference will be there from someone that wrote JAMB just once and gain admission. Even sometimes when I bring Tommy here, when I ask Tommy if I bring her here to come and talk to you, Tommy just like this. What do I want to tell these people? Me, I wrote JAMB once. Supposed to every once. I get admission once. So what do I want to encourage them? So, but someone that wrote 5 times will easily tell you not to give up because the person has passed through the stage. Someone that wrote 2 times will easily motivate you. When was it Dangote that was telling the story of when he started one business, that one crash, he started another one, that one crash. Look at what happened recently now that Dangote used all his daughter as the head of his refinery or his company. All his daughters.
How many daughters?
Imagine I have conflicts now. I'm not putting it on my child here to be the head. They might not understand my struggle. They might not. How I got there, they might never understand. So please, the journey of life comes in different forms. The best you can do to yourself is to encourage yourself and move on. I was telling the parents, please, many of you had the news then. I've had different experiences. There was a time before we used to stop physical exam. There was a time some students went to write post-UTME. They finished the exam, they were coming from Moro. Their center was Moro. They were coming back to Ife. The 2 boys, they were on the bike. And while their bike wanted to cross, they were crushed by a truck. And the 3 of them, the bike man and the 2 boys, they died. With those ones we're talking about, I don't understand stoichiometry now. They won't be telling you that now. Same time, some people just gain admission. 1 week into resumption, 1 girl fell into sock away and died. Did you hear the news that time? Things happen. The one that they did, was it that JAMB did not go well last year and went to poison herself? What has that changed? So please, be encouraged to face your struggle. Oh, dear, but when the problem is, you get to start to pay no water. Yes. Oh, okay, one more. We have to pay no water. As long as I have life, I have hope. So I will keep trying until God's glory will come manifest. So please, When you're talking about empirical and molecular formula, it's another way. Please listen now. Yaruka, listen. Adeshewa. Now, when you're talking about empirical and molecular formula, I know all of you know this. It's just expressing the ratio in which those elements combine. The ratio in which they combine. If I write CaCO3, empirical and molecular formula will tell you that I have one atom of calcium, one atom of carbon, and 3 atoms of oxygen. So I cannot say they combine in the ratio of 1:1:3. So the ratio in which all of them come together. If I say what is the ratio of boys to girls in this class, we know the total number of boys, the total number of girls. And in this population, boys are always more than the girls. So, because it's boys that used to want to go to school. So let's say this is the actual number of boys to girls. Now, molecular formula tells us the actual number. Empirical formula tells us the simplest representation of the numbers. The total number of boys in class, 64. The total number of girls in class, 32. What is the ratio? In the simplest form, this is 2:1, Abi. So I can say the total number of boys in class is 2:1 to girls. So that is what this one is saying. So in a case like this now, this is C6, A12O6. All of you know what this means. This is glucose, Abi. This is the actual value of glucose. You always have 6 carbon, 12 hydrogen, 6 oxygen in glucose. But this can be referred to as the molecular formula. And the simplest ratio is going to be 1:2:1, Abi. CaO. This one will be referred to as the empirical formula. Is that taken? If you look at what I have here, look at this guy. This is water. There are some compounds that their molecular formula is the same thing as their empirical formula. Don't get confused. The molecular formula for water is 2:1. The empirical formula is also what? Because you can't simplify this again. It will still be what? 2:1. Do you get that? So, what is now the difference between empirical and molecular formula? For simplicity, empirical formula shows the simplest ratio. The simplest ratio of the number of atoms in a composition or in a compound. The simplest ratio. That is empirical formula. Molecular formula shows the actual ratio or the actual value of the number of atoms you have, the actual value. So the exact ratio, the actual ratio of the combination or the number of atoms when they combine in a composition is called the molecular formula. But the simplest formula is, so e.g., glucose. The actual ratio for glucose is C6H12O6. The simplest ratio is CH2O. So the simplest ratio is 1:2:1. The actual ratio is 6:12:6. Is that taken? So as simple as that. Now, when you want to solve problems on empirical molecular formula, what is the rule you follow? Number one, they will give you the mass composition, mass or percentage composition. That's the one. So they will give you the mass or percentage composition. Rule 2, they might not give you, you might be the one to calculate it yourself. Rule 2, you divide this mass or percentage composition by atomic masses. That's root 2. So when they give you these values, you divide it by the atomic masses. Are you there? Root 3. Then after dividing, you look at the values you have gotten. Then you divide through. Divide through by the smallest ratio. So if you are to determine empirical formula, this is the rule you follow. So you divide through by the smallest ratio. Then finally, if your answer is whole number, if what you are gotten is whole number, then you are good to go. That will be your answer. If your answer is not a whole number, then you have to do something else. If your final answer is not a whole number, then you go to the next rule. Multiply by integer. So if it is not a whole number, you multiply your final answer by sets of integers. Is that taken? So the integers can be, you multiply by 2, 3, 4, 5, until you get a whole number. That's it. So to now determine molecular formula, so for you to determine molecular formula, you will now say that empirical formula into N will be equal to molar mass. Empirical formula into N will be equal to molar mass. So that will help you to determine molecular formula. So N will represent the ratio, the actual value that you are going to get. So let's pick problems. And drill ourselves. Question 1. Oh, note something too here. Before you start problems, notes. Total composition is usually 100%. So when they give you the percentage composition of one element, two elements, and they say determine the empirical formula, check the total composition. It must be 100%. If it is not 100, that means there is one element that is still present. You will see examples. That means there is one element that is still present. That element is usually oxygen. And that oxygen is usually obtained by what we call method of difference. So you are going to add the ones they give you, then you subtract it from 100. Then that will give you that of the elements that they didn't tell you. Most of when carbon and hydrogen are present, then you will add the two together. It's not 200. That means what is left is for oxygen. We will solve examples and you will see. But let's take them one after the other. So this you need to note. And don't forget, you have done organic chemistry. When you hear the word hydrocarbon, anytime they tell you hydrocarbon, that means that compound is made up of hydrogen and carbon only. So let's solve problems. Problem 1. Are you ready? Are you still writing? We are less than fast. Let's just solve all the possible questions they can ask you under these aspects before we move on to the next thing. Are you true? Are you ready? First question. A compound has the following composition. A compound has the following composition. 1.33 gram potassium. A compound has the following composition. 1.33 gram potassium. Some people, these were all the questions they were just saying last year in their exam. Oh, this exam when you know 1.33 gram potassium, 1.77 gram chromium. I pray that April I have a slight time so I can come and give you some problems. 1.77 gram chromium and 1.90 gram oxygen. 1.33 gram potassium, 1.77 gram chromium and 1.90 gram oxygen. Full stop. Calculate the empirical formula of the compound. Calculate the empirical formula of the compound. K equals 39, Cr equals 52, O equals 16. Calculate the empirical formula of the compound. K equals 39, Cr equals 52, O equals 16. Oh, oxygen, oh. So now, how do we do that for the sake of learners? Your rule states that they will either give you mass or percentage composition. In this case now, they're giving you masses, Sabi. So what are you going to do? Divide by their words, atomic masses, Abi. So you list them out. What are the elements you have here? Let me solve it here. So that you all can see. Because only the blind can see. So first is the mass composition that you are given. And for all of them you have potassium, you have chromium, and you have oxygen. So you have been given. So the mass composition for potassium is 1.33, Abi. Chromium is 1.77. And oxygen is 1.90. Are you there? Then even if you are switching to science, the JAMB class, they don't demand it. Have you written WAEC? Have you? You have to switch to science, maybe you go for WAEC class. Or you combine both, the JAMB and WAEC class. So now we have their mass composition. So you divide by their words, atomic masses. What's the atomic mass for potassium? 39. What's the atomic mass for chromium? That of oxygen. Right? So that's the, I'm applying rule 2 now. Oh yeah, rule 3. So after I got your value, what's the answer? The first one. Always approximate to up to 4. Don't just approximate anyhow so that you don't get, you don't have issues. What's the answer for this? What's the answer for this? So these are the answers. The rule 3 states that divide through by the words, by the smallest. So which one is the smallest here? Abi? So you now say divided by 0.0340. 0.0340. 0.0340. Is that clear? What would this be? What would this be? What would this be? Now look up everybody. At the end, do you understand what you have done here?
Yes.
You don't just say KCR 3.5. Look at rule 4. Rule 4 says that if it is a whole number, then it's fine. But if it is not a whole number, then you move on to rule 6. That means you multiply by integers. Is that taken? So from what you have here, you cannot represent it. So rule 6 says that multiply by integer. So you take 2 first. If you multiply 2 by 2 and you still did not get integer, you will take the next number. Don't mistake people used to make here again is that if they multiply 2 by 2 and they did not get the integer, that's how they get. They will now multiply that one by 3. No, you multiply this by 2. If you did not get, you multiply this again by 3. If you did not get, you multiply this again by 4. Not like Mama multiply alone. I don't know if you understand that statement. People used to make that mistake, I'm sure of that.
I don't
So,
understand.
what do you...
I don't understand.
Now, listen. I said something. You want to get a whole number. So the rule to get the whole number is multiply by what? Integers. Abi? So you can multiply by 2. After multiplying by 2, if you have gotten a whole number, then... But if you multiply by 2 and you didn't get the whole number, let's say, for example, let's say I multiply this by 2, then this will give me 2. Don't worry about this. So let's say this give me 9.5 at the end. Then I will be asked to multiply by 3. Since after I multiply by 2, so what I have still didn't give me a whole number. Then I will be asked to multiply by 3. So I will go again, multiply by 3. It is not this one that will multiply by 3. It is not the answer I got that will multiply. I will multiply that same value by 3 again. That's what I'm just trying to pass. So here now, what do we multiply with first? So that will be 2 times 1. 2 times 1. 2 times 3.5. So now you have a whole number now. So the empirical formula is now going to be what? Now the name of this compound will be potassium 7. So potassium 7 is heptaoxodichromate 6. Potassium heptaoxodichromate 6. That's the way we determine that. 14 minus 2, 12. 12 divided by 2, 6. You will do that when you do oxidation and reduction. You understand it? Don't worry. You can do the calculations. Next question, yes sir. Let's look at this question. A hydrocarbon. Are you writing? We are right. Where you actually let me know? This is power bank. This is power bank. This is power bank. That charger is the thick one. White. Hey! The hydrocarbon is analyzed. The hydrocarbon is analyzed and found to contain. The hydrocarbon is analyzed and found to contain 83.3% carbon by mass. A hydrocarbon is analyzed and found to contain 83.3% carbon by mass. Do that, we need to move in. I'm going to go so you want that you will sharpen. 3.3% carbon by mass. Full stop. What is the empirical formula of the compound? Question mark. What is the empirical formula of the compound? Question mark. C equals 12, H equals 1. Les sauve, les mener, les get, the answer, les passo. That means solve and get the answer and we proceed. It's not over. I should repeat the question. A hydrocarbon is analyzed. A hydrocarbon is analyzed and found to contain 83.3% carbon by mass. Full stop. What is the empirical formula of the compound? Question mark. That's all. Carbon is equal to 12, hydrogen is 1. Think about it before I solve it with you. You to try. Look at it. What do you think is happening? Like, just look at it. What do you think is happening? What's your brain saying? It's okay not to know it at first. It's okay to adapt. Don't worry, just keep praying for us. We want the best for you. Keep praying for us. God will do it. Oh yeah. Have you got your answer? Yes. What's the answer? C9H12. How many of you got? I don't know what the answer is. Is there any other answer aside that? CA2 is in the option. CA2 is in the option. C5H12 is in the option. Which other answer? C2H5 is also in the option. C2H5 is also in the option. yeah, without wasting much time, let's look at it together. So please, the first statement says that what? An hydrocarbon. At the moment you hear hydrocarbon, what does that tell you? That means it's made up of carbon and nitrogen only. They now said it's made up of 83.3% carbon. That means that mass of carbon, percentage of carbon is what you are given. Did they give you that of hydrogen? So how will you know that of hydrogen? You subtract it from 100 because you know everything should have been 100. Is that taken? So now carbon 83.3%. So you are given their percentage composition. Then hydrogen must have been what? 16.7%. Do you all understand what we have done here? Because you know it should be 100. And they now told you that it is hydrocarbon. That means it's made up of carbon and nitrogen. And if carbon is 83.3, share one. So they might give. If you already know it, please keep quiet. So that those that do know it, please keep quiet. So that those that do not know it, they should enjoy it. Let them learn and listen. So the smallest is this, Abi. So then you divide it by the smallest. 6.9417. 6.9417. Normally, because this is, we could have approximated it to the same value. But let's do this. So what would this be, one, Abi? What would this be? 2.4, Abi? Now that you have 2.4, can you just leave it like that? Since you didn't get a whole number, so next step is multiply by integers, Sabi? So first thing is multiply. If you multiply by 2, you are going to have 2. That is also not a whole number. But it's something you can actually approximate, but you have to check first, don't approximate. It's after you have tried several ones, then you can now do the highest and approximate that one. So this one did not work for me yet. Then I will multiply by 3. Did you see what I did now? It's not my answer that I multiplied by 3. It's the same answer that I multiplied by 3. That's what I was telling you. So now this will give me 3. What will this give me? Something 0.2 and 7.2. That will not also work, Abi. So what do I do? Multiply by 4. 9.6. That will not work. Multiply by 5. This will give you 12, Abi. That's your answer. So this will be 5. And this will be 12. So your answer is what now? C5H12. Which compound is this? Is it an alkane or an alkene? Alkane. It's an alkane. Because that's CnH2n plus 2. Is that taken? Yes. Thank you. So you see what? This is just the problem. And that's what we have done here. So let's look for another problem quickly. Don't worry. Well, by 12 I'll give you a break. Then by 12:30 you come back. We do, it's either we do physics or we do reactions to geometry. So we go to most by 2. There's no most today. By 2. What is the empirical formula of an oxide? We have 30 minutes break, then we do reactions to geometry theory. step 2. Then you can go home. What is the empirical formula of an oxide containing 72% manganese by mass? What is the empirical formula of an oxide containing 72.0% manganese by mass? Mn equals 55, O equals 16, and do the rest. 55. Mn is 55. What is the empirical formula of an oxide containing 72% by manganese by mass? 72% manganese by mass. So after that, we'll now come back for reactions stoichiometry. But make sure you eat very well. We'll break. We have to mommy. We shall make you are fasting. Sorry. Make sure you are strong for the class. So just rest, just walk around, stretch your body, do basic exercise, then come back by 12:30 to do reaction. This is the end of composition stoichiometry. Then we do reactions stoichiometry tests. Then when we are through, I will now come and teach you the results again. We will solve problems of the results. Just go and look for more questions to solve. And anyone can solve, meet with your friends. If your friends can't solve it, let me know in class. Then I'll help you solve it. If I cannot solve it, you take your story to God. But there's a labor. It's only God that can solve the problem we all cannot solve. What's the answer? It's gone. August. What's the answer? It's still there. It's in decimal. What are you supposed to do? But I'm multiply a lot of my guess. And answer not. Are you true? What's your answer? Oh yeah, now, so that I want us to solve like 2 more before you go for your break. That's really oh yeah, let's already contains all the payment periods. So it will be stamped. And an organization that wants to run well has to run properly. Which means that you might come tomorrow and you will see gatesman at the gates. The only thing that gives you access into the class, into the compound, is your card. No card, no access. We might not even, the secretary might not even check the seat. It will start from the placeman before the secretary for further verification. So, according to Google, that is called 2 ways authentication. So, all of those things, they matter. They matter too. So please, that's what you are going to be doing. What's your answer? So no cash is accepted again. You have to transfer. See what? This is 86. That is aromatic or that is benzene. Did you all get the answer? Can we do it together quickly? So after solving this one, then I'll give you one more. Then you solve that on your own. Then we'll see the next class after your break. So the compound says that you should determine the molecular formula of an organic compound containing carbon, which is 92.31%, and hydrogen, which is 70.69%. So you first to determine molecular formula, you need to know molar mass and empirical formula so that you get the actual ratio. Divide this by 12, divide this by 1. What will this give you? 7.6925. What so divide by the smallest. What will this give you? So this one is 1. This one is 1, Abby. So the empirical formula is 1:1, and that is saying CH. Abby. So now that we know the empirical formula, let's determine the molecular formula. Honestly, you cannot tell me that all students really tell itself. Yeah, I know that yes, I'll just be happy. But if people will enjoy it, some will get shorter, some will get faster. So now we have the empirical formula into N equals molecular mass. So now that this is CH, what's the molecular mass given? I hope you are following. So now CH, carbon is 12 plus hydrogen is 1. Then it's N equals 78. So that would be 13 times N. That would be what? 13N is equal to 78. N is going to be 78 divided by 13. And that's going to be what? So now that N is 6. So you are saying that CHN is the same thing as saying CH into 6. 6 times N. 6 times carbon. 6. So that is the molecular formula. So question for you to practice on your own. Then go and solve your past question. What is the molecular formula of cryolites? So that you go on your break. I have 2 minutes to give you this question. So you go break by 12 and come back by 12:30. What is the molecular formula of cryolites? CRYOLITE, cryolite. Is the molecular formula of cryolite. If it contains 32.85% sodium, if it contains, what is the molecular formula of cryolite? If it contains 32.85% sodium, 12.85% aluminium, and 54.3% and 54.30% fluorine by mass. If it contains 32.85% sodium, 12.85% aluminium, and 54.30% fluorine by mass. Question mark. The relative molecular mass of the compound is 210. The relative molecular mass of the compound is 210. Sodium equals 23, Al equals 27, F equals 19. L equals 27, Na equals 23, F equals 19. What is the molecular formula of cryolite if it contains 32.85% sodium, 12.85% aluminium, and 54.30% fluorine by mass? The relative molecular mass of the compound is 210. So, by 12:30, we'll start reactions stoichiometry so that we'll finish everything stoichiometry so that I can go and practice it for the weekend. So tomorrow, when I come back, I'll give you time for physics. So we can do physics and other things. So I will continue. I will leave the AC circuit. I'll come back to current electricity. Because some of you, because you did not understand some things in current electricity, it's making it hard for you to understand AC circuit. So I'll try and come back to teach current electricity before we come back to AC. By next week, I will have next week with you guys. So let's